circle geometry. Give me a sec. We shall have basic introduction to the topic at first, and then we'll see where Mr. Ido is going to come in and continue his topic from next week. Okay, circle geometry. At first, let's get introduction to what is even a circle. A circle, by its math definition, is about the movement of a single body such that its distance from a fixed point is always the same. Now, this is a center. Okay, we call this a center, and then there's a particle here. If this particle is moving, every time this particle is moving, the distance, look at the distance, this particle that is about to be moved, this is our point P1, distance from this particle to a center, okay, let's call it distance D. We change the level. If this particle moves to this point, P2, if you measure this particle is now here, if you measure the distance to this side, it is always the same. If the distance is 12 centimeters, if it moves, it is always 12 centimeters. So the distance, the circle is the locus. But we're not looking at that. It's the locus of a point. This is the point that moves such that any location it gets to when it is moving, its distance from a fixed point. This is a fixed point. This one is FP, fixed point. What is it of fixed point? A point that does not move, that just stand alone, that remains like that. But P is a point that is moving. There are 2 points. This is a fixed point that does not shake. It does not move. It remains there every time. But this one here is moving every time. It's moving. So you can see. So if it's like you have a wood that you hit on the sand, you put something, maybe a rod, you pin it, use a mat to hit it on the floor, and then you tie a rope around it and stretch the rope to an end, such that if you move around it, the rope will not be rolling around and then you'll be shortening your distance. The rope will be moving. As you're moving, you see that you'll be creating a circle. Use your feet to draw a line as you're moving. You see that you draw a circle around this fixed point. So this is the fixed point. So circle is always defined as the locus. We'll tell you about locus later. As of a point, which is the point which moves. As it is moving, is getting to this point, P3, getting to this point, P4, getting to this point, P5, getting to this P5, then P6. Anytime, any location it gets to, if you measure the distance from that location to that fixed point, that point that does not move, it's always the same. Do not mind my diagram, it's not accurate, but that is what we call a circle. A circle has a fixed center, and it has something, a line, thin line surrounding it. There's a fixed center, which is known as this, and then there's something surrounding it. Then let us now see what are the names of the or some parts of a circle. So a circle is the locus of a point. This is the point which moves such that along its path of motion, anywhere it gets to, its distance from where it gets to a fixed point that does not move at all, which is known as the center, is always the same. Okay, so now we will not tell you that fixed point that does not move is called the center. The fixed point that does not move is called what? The center of the circle. Okay, so the point that is moving, the point P that is moving, as it's moving like this, the name of the what it describes, what the name of this shape is called circumference. The line, this thin line you see, is a thin line. Okay, it's called circumference of a circle. Circumference. So as the point moves, what it describes is a circle. But the name of that thin line is called circumference, or another time we call it perimeter. Say, what is the distance surrounding a circle? That distance is called what is find the perimeter or find the circumference. So you can call it perimeter. Perimeter generally means the total distance surrounding a shape. If a shape looks like this, let's see, you understand it better now. If a shape looks like this, you know this is called a square. They say this distance, it is a square. The distance are always the same. It is 2. And 2. They say find the perimeter. Perimeter means the total distance surrounding a shape. This distance from, we call it A, B, C, D. Distance A to B is called 2. Distance B to C is 2. Distance C to D, 2. A to, so what is the name of that distance? It's called perimeter. So find the perimeter of a square, add up all the distance to it. If you walk 12 kilometers to your school, by you walk actually, then you also walk that 12 kilometer, but that's what is your perimeter. Add the distance that you take throughout the journey for going and coming. That's called the perimeter. If a shape looks like this, let it be zigzag, whatever. They say, what is the perimeter? Add this part, 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 add the total surrounding around that shape. The name of that thing you get is called perimeter. But for circle, we are allowed to call it another name again, known as what? Circumference. Let us now see parts of a circle. Parts of a circle. Name and parts of some important part of a circle. Now, I said here that the name of that fixed point that does not move is called the center of the circle. This C is called the center of the circle. And then the name of this P that moves, okay, what it describes as it moves is called the circumference. Now, the distance between any part of that circumference and that center that does not move, the distance is actually called radius. Distance, when it gets to this place, if you measure the distance to that part that does not move, it is always R. When it gets to this point, measure it down to the center. It is R. If it is R is 7 centimeter, it will be 7 centimeter anywhere along the circumference drawn to the center. I have said, do not mind my diagram that does not look accurate. I'm drawing with hands, not technology stuff. Okay, so it's called radius. So distance from center to the circumference, that is that curved part, that point that is moving, described, that is map out. That part is called circumference. So any distance from that fixed point, known as the center, to anywhere along the circumference or the perimeter is called radius. Now let us see parts of a circle. Parts of a circle. Parts of a circle. Okay, I'll tell your master that I've covered all these parts, so we'll go properly to the theorem. If we are able to get to the theorem today, we'll do. Now, you see, let me draw one small circle here. We are now aware that this point in math, either we usually use letter C to represent center, from C, center, or we use O. O is what you are going to say, a circle of center O. That is letter O. Okay, that is, letter O. Now, let us try to see some part of the important part. You see, what is called this is a line coming from center to the circumference, or from the circumference, anywhere, I can draw it anywhere. From here, from the circumference to the center, is called R. It's called R. Anywhere you draw it to, it's called R. So R is called the radius. Radius. I'm going to define something for you. There's what is called a chord. I'll tell you something now. A chord. What is a chord? A chord is a line that cuts a circle into two. A line that cuts or divides a circle into two. Cuts or divides, cuts a circle. I didn't say equally, a circle into two parts. If a line is such that it touches 2 points of the circumference, this line I tell you is called circumference or perimeter. So if I pick a point here, I call it point A. I pick a point here too, I call it point B, and I draw a line to touch the 2 points. See, it has been divided to two parts. One big part, maybe this part, and then you cut into two, and then this small part again. That line that does that cutting is called a chord. So long as a line, you can see it's a radius, it's different from a radius. A radius is coming from this circumference and it ends at the center. A line from the fixed point that does not move, which you call center, to any part along that circumference is called radius. So a radius is touching a circumference and the center. But a chord is touching 2 points on the circumference. This is part here. This surrounding is called circumference or perimeter, but we'll be using circumference. We love to call it circumference for circle. But any other shape, the distance surrounding it is called perimeter. It is also perimeter for a circle, but we prefer that name. The name is circle, then circumference. You can see it goes well. You can call it perimeter, but I'll be using circumference most. You can see a chord touches 2 points. It cuts a circle at 2 points on the circumference. So if I draw one like this again, vertically like this, you can see, so long as it cuts the circle from this point and the circumference, and it goes to this side again, it has divided into two. If I split it now, one goes to the left and the smaller one to the right. So any line that cuts a circle is called what? A chord. C-H-O-R-D, chord. That is it. Now, there's now a special chord that divides a circle equally. It is also a chord, but it has a special name too. I told you now that distance surrounding any shape, even if a circle is perimeter, but for a circle, it has a special name again called circumference. We cannot call the distance surrounding a square, a kite, a rectangle, a rhombus, a parallel, a trapezium. We cannot call it circumference. We only use perimeter. But for circle, it is allowed a special name called what? Circumference. It's like everybody is, this class, we have boys, we have girls. Bello is a girl, Miriam is a girl, Emmanuel and Olamekon, they are boys. But you have special name again. We have boys, we have girls. It's a general name. We have a special name called Olamekon, a special name of a girl called Miriam. Bello, what's okay? Don't open mic now. That name is not yours, I know. I'll ask for your name later. Okay, I don't want anybody to interrupt this class until I ask you to open. Okay, sorry, am I sharing my screen? Oh my goodness. Okay, am I sharing? Okay, I'm sharing. Okay, yes, I'm sharing. So let's go. So, what is the special name for that chord that divides a circle? I'm not asking you to open mic. I'm going on. Well, let us see. Now, a line that cuts a circle into two parts, whether equally or not equally, whether one is big, but it divides it. You bring a bread, you divide it to two child. Maybe one is older, you give him a big one. So long as you are divided into two, if it is a circle, that name is called chord. So that you divide it to two. Maybe the announcement is you don't want to try to divide it equally. It is still chord. But the one that divides equally has another special name. Let us see that. Yes, this is the center. You see this property now. A line that goes like this is called a chord. It divides into two. This is also a chord. It divides it into two. But one is bigger, the upper one is big, the lower one is small. But this one, the upper one is small, the remaining part in the down is big. You can cut it vertically too, like this. Okay? I'm not using, I don't. Now, what about this one that cuts it? You see, what matters? Some students say, what's the name of this? Is it a chord? You say no, it's diameter. Yes, the name is diameter. That is the special name. A chord that divides a circle into two equal parts. Or another way, a chord that passes through the center. You can see this is a chord touching this part of the circumference, touching this part of the circumference. That is what makes it a chord. This is also a chord. It touched this part of the circumference, it touched this part of the circumference. It's a chord. This part too. It touched both parts of circumference, so it's a chord. But as it is going, it passes through the exact center. It touched the center too. So it has a special name known as what? So this is a chord. Sorry, that modeling is on to, let me put it like this. This is known as a chord, C-H-O-R-D. This one too is a chord, C-H-O-R-D. Why? It cuts a circle into two. Or it touches two parts, it cuts two parts of the circumference. Now, this one too follows that definition. A line that cuts a circle into two, that is, it touches two parts of the circumference, is a chord. Now, this is also a chord. Let me bring it out. It's a chord, so long as it meets that definition, a chord. But because as it is cutting the circle, there are two things about it. It cuts, somebody is trying to comment. Sorry, let me add that person in first. Sorry. Okay, Mr. Ismail, that's Mr. Ismail. Okay. So, so long that it meets that definition that it is a line that does something, it divides the circle into two. Why? It touches two parts of the circumference. It touches this part of the circumference, it touches this part of the circumference as well. That is a chord. This one touches this part of the circumference. It's also touching this part of the circumference. That is a chord. This particular one that is going touches this part of the circumference. It touches this part of the circumference. So the name is also a chord. So a question was asked in an objective paper that say, which of these is not a chord? And then they want to confuse the student. They say, which of these is not a chord? In the name, they mentioned that they pick the student among the option, they pick diameter. Diameter is also a chord, so long as it meets the definition that any line that cuts a circle into two, whether equally or not equally, okay, is a chord. So long as it touches two parts of the circumference, it's a chord. So this line is a chord because it touches two parts of the circumference. But it does an important thing. While other chords divide the circle into a part that you have a bigger part and a smaller part, like this one, this top that I'm about to shade down is small, but the remaining part is big. This chord, this part that I'm shading downstairs is small, but the upper part is big. But this one, that is also a chord. Why? Because it cuts the circle into two by touching two parts of the circumference. It's also a chord. Why? It divides into two. But it is a special chord because one, it divides the circle not only into two parts, but two parts that are equal. That is one. Two is that as it is going along the parts of this chord, it passes through the center of the circle. That point that is called a fixed point. We said there are points, different points. There are moving points and there are fixed points. The fixed point is what? The center, and the points that can move is what describe this part of circumference. Okay, so those ones are the moving points, but the fixed point is the center. So a chord that passes through the center, one, or that divides the circle into two, has a special name known as what? Diameter. Okay, we are looking at different parts of a circle now before we go into the theorem. Now, let's see the special name again. So it's a special name. So it is a chord, please. It's a chord. Now, let's see special name to each division. We said this is a circle. This is a chord, okay? If this is a chord, look at this smaller part now. We have a smaller part here. Sorry, my sketch is not perfect. This is a bigger part. The name of the individual parts that a chord divides a circle into is called segment. So this is a segment. Let me put it here. This smaller part you see here is called a segment. We'll call it a special name, segment. Segment of what? A circle. We are looking at part of. So the remaining part, let me show that in a different diagram. Okay, this is the smaller part cut by that chord, and this is the bigger part. So this is a segment, but because it is small, we call it minor. Minor is so minor segment. Minor segment. The minor segment of a circle. And what is the opposite of minor? Major. This is the major segment. Major segment of the circle. Now, the same thing happens to this one. This chord down here, the upper part becomes the major segment, and this lower part is smaller, it becomes the minor segment. Now, so long as the chord has divided a circle into two, it has divided it into what? Segment. The bigger one is so it can divide it vertically. Is this line a chord? Yes. Why? It divides a circle into two. If you want to do that, you see one bigger part here and the smaller part here. So these are segments. This right one is the minor segment. This is the major segment. So not only that. So if I call this one two, this one passes through the center and divides it into two. So it's also a chord, but because it passes through the center and because it divides the circle equally into two parts, one on the left, one on the right, but both of them are equal. It's a special chord known as what? Diameter. It can cut it this way too. You can see that line. It passes through the center and it touches the two parts of circumference. It is a diameter. This one too, like this. It is a chord that passes through the center. Therefore, it is a what? A diameter. Now, let's see. We said the name given to the two parts is called segment. Now, because the line that passes through the center, which is a chord, which has a special name known as diameter, the name of the segments also have special names. Let's see. The name of the division, this is a circle. And this is a chord, this is the center. This is the chord that passes through the center. This is a segment. This is a segment. You know, the other division have minor segment and the other one have major segment. But these ones are equal halves. A bread is divided into two between two twin brother. If it is bread, if you have an older brother and a younger one, the parents want to divide it unequally. That's what the chord does. One bigger bread and the smaller bread. But two equal bread for the twins. Okay, so this one is called, because this shape is called a circle. Okay, half is called semi or hemi, but we prefer semi. So half, semi-circle, half of a circle. Semi, S-E-M-I, then circle. So the upper part is a semicircle the lower part is a semicircle. But are they segments? Do not open your mic until I want you to do so. They are segments, but the segments are equal. No major segment, no minor segment when the chord is a diameter. So this one too, like this, that passes through. The left part is a segment. The right part is a segment, but no one is big, no one is small. So there's no major, there's no minor. Both of them are half of a circle, known as what? Semicircle. Okay, now let's proceed. Let's proceed. Now, this is also a circle. We have known what a chord is. We have known what a segment is. Now, we've told you what a radius is. Although that's been done earlier, we said there are some points. This is point P1, P2. As a point, there's a point here that does not move at all. We call it a fixed point. It is known as a center of the circle. And this point can move. This is how I started. This is a point, okay, that does not move. Fixed point, FP, fixed point. And there's another point here, point P. It is allowed to move. So it is moving like this. It is moving like this. It is describing a shape. It is moving such that anywhere it gets to this point P1, point P2, point P3. Anytime, anywhere it gets to as it is moving, but you measure the distance between anywhere it gets to and that fixed point that does not move at all, you get a fixed distance, which if, for example, we call it D for now. If the distance is 2 centimeters, when it gets to this point, if you measure it again, it is also that D, 2 centimeters. When it gets to this, you measure the distance from anywhere you get to that fixed point that does not move. It is always the same. So we call a circle, I've defined it before, I'm not going there again because that topic is locus, it's a different topic now. So, but so long as this shape is moving, so we now draw it with a thick line now. It describes what is called a circle. And this surrounding is either cos, perimeter, or but we prefer to call it circumference specifically for a circle. Okay, so this distance from the fixed point, which is called the center, the fixed point is called a center, and the moving point is called circumference. The shape it describes is called circumference. The distance between that fixed point and the center is called radius. Okay, now there's something I want to show you. We'll discuss. Okay, we want to describe one thing again. I'm coming back to this shape. Let me go above again. Let me go here. Now, look at, we said the distance from the center to the circumference, okay, is called radius, and it's measured anywhere. Let me use another diagram for clarity. Okay, now, what about this? Look at this now. This one passing through the center. It is a chord. For passing through the center, it is a diameter. Okay, now, distance from center down to this circumference, we call it radius. Agreed. Even from here, from center to this part, is also radius. So from this center to the left, to the right, is called radius. The same distance from the center to the left is also called radius. But the total is called diameter, letter D. So let's come to see something now. You can see that this distance from, let me call this point A, and then this point B. So the distance of the length coming of this chord AB, chord AB is a chord which is called diameter. So AB is a chord which is also the what? Diameter. I want to say something. Diameter. Before we go. Now, but we know that from only this center, okay, down to the right, it is called radius, R. From only this center down to the left, it's also called radius. That means inside a single diameter, there are 2 radii. Okay, the plural is radii, R-A-D-I. So AB, let me mark this center C. We want to go from your house, okay? There's a straight line from your house to the market, and then from market to church. And the distance, the total distance may not be equal. Okay, from your house, this is, I'm no longer sharing screen. My apologies, sorry. I'm sharing. Please, any other person should unmute, and then let me stop sharing now.